Despite what my ex-girlfriend says, size doesn't matter, bigger isn't always better. In our case, we want things as small as possible, things that are tiny, so tiny. What if I told you I was holding the future of science in my hand? This device is highly advanced and will be used around the world in a matter of years. The future we see for our society is one involving nanotechnology. You obviously can't see anything remarkable, just my bare hand. That's because I don't actually have an example of nanotechnology with me today. But with nanotechnology, you wouldn't be able to see anything in my hand with your naked eye anyways, because these new products are going to be so incredibly small. Nanotechnology is an area of science being used to manipulate objects like these particles and cells. To get a better grasp on how small of a scale I'm talking about, imagine a marble. If the marble's diameter was 1 nanometer, then on the scale, the diameter of Earth would be approximately 1 meter. Nanoparticles will be on the scale, so you wouldn't be able to tell if I was holding anything. These manufactured particles are the future of science and will be developed to create products that will be used in medicine, environmental cleanup, and many other fields. All of these fields are showing promise, but we believe environmental cleanup, namely the removal of water and air pollutants, has the most global upside at a reasonable price at this time. In 2010, BP spilled over 210 million gallons of oil into the Gulf of Mexico. There wasn't anything at our disposal to clean this spill effectively without causing further damage. We couldn't burn the oil off the water because that would pollute the air. And we couldn't simply scoop the oil off the surface of the water. There simply wasn't an effective solution to clean up this disaster efficiently until now. With advances in nanotechnology, products are being developed that can filter water in safer, more efficient ways. One of these products is a sodium silicate coated mesh. This material possesses oleophobic properties. In other words, these materials allow water to go through without letting the oil pass. This has been utilized to create a net that can be placed in oil-contaminated water that will separate the oil from the water. Chemical properties assist in the removal of oil, but the mesh-like structure is also a key component in this purification. Additionally, these structures utilize the UV rays emitted from the sun for self-cleaning. This effectively eliminates the need for any kind of maintenance or upkeep. Water filtration is a field of nanotechnology already under development. The products that are being manufactured and tested have shown success in purifying and decontaminating the water. While these filters are showing promise and have had success, they are still undergoing testing and haven't been implemented on a large scale. Potable water isn't a readily available resource in most areas of the world, which is how this filtration method took root. In fact, only 3% of the water in the world is fresh water, and only 1/6 of that is available fresh water. Not only will we be able to remove oil from water, we'll soon be able to clean groundwater using nanofilters, as well as making drinking water available to the people around the world. With the world's growing population and industrialization of our society, air pollution is also becoming a more prevalent problem. China is one country greatly affected by air pollution. Here we have a picture of Shanghai from 1995. Now here's a picture of Shanghai from 2013. Since China is a predominantly industrial country, air pollution has been increasing significantly and is causing various problems. According to the New York Times, China's contaminated air has contributed to 1.2 million premature deaths in 2010, which accounts for approximately 40% of the global total. Nanotechnology is being utilized to address air pollution. There are currently 2 ways nanotechnology is being used to reduce air pollution. One is catalysts, and the other is nanomembrane structures. Catalysts are used to induce a chemical reaction that changes a particular molecule into a more desirable molecule. The main idea with the catalyst is being able to convert harmful gas molecules to less dangerous ones. One trait of manufactured nanoparticles is their large surface area to volume ratio. Since catalysts are composed of nanoparticles, they have a large surface area allowing them to interact with the contaminants. This gives catalysts the ability to absorb a large amount of pollutants and speed up the reaction. Metal oxides such as gold are being used as catalysts for air purification. Nanomembrane structures are membranes that allow certain molecules to come in while blocking others from passing. The membranes are like those big bouncer dudes in clubs that allow certain people to come in on their list and while keeping everyone else out. These nanomembrane are being used in the exhaust streams of industrial plants to separate carbon dioxide from the air being emitted. The world we live in today is plagued with problems that will not go away when we close our eyes. As mentioned today, one of these obstacles is pollution. It affects the majority of people, spanned across the globe, and presents in a multitude of forms and will continue to affect future generations unless it's addressed now. One would think that such a large-scale problem would require a solution that matches magnitude. Nanotechnology offers a solution that tackles the problem on a molecular level and attacks the problem at the source. If we can tackle the problem of pollution through nanotechnology, then there will be other problems that can also be addressed using this small-scale technology, opening up nanotechnology to more fields. For these huge problems, there are small solutions. That's the future around the corner. Now, who wants to help change the world?